Hi Stat students, today's lecture is about data wrangling in SPSS. So I'm going to use Google Slides to show pictures of what SPSS would look like, and then I'm going to talk about some of the effects you might have. So the first thing that we want to talk about in data wrangling in SPSS is how SPSS stores information. So SPSS stores things as variables. Each column is a variable, and each variable has a type. What I've been calling variable type, SPSS calls a measure. So every column, everything in each column has to have exactly the same type of data. And so you can edit that not in the data view, but in the variable view tab. And SPSS won't let you enter data into variable unless it fits the format it expects. So for example, here is some finger length data. And so left pinky here has a ruler next to it and it's numbers. So it's expecting numbers. So if I try to type like the word like FGF here and hit enter, it'll be angry at me because that doesn't work. If I wanted to change, so this is the data view, if I want to change left pinky to allow text, I go to variable view and find left pinky, and I might change it to a different type of variable, like string. I'm not going to do that because I don't want that, but this is where I would do that. So SPSS contrasts between discrete and continuous. When I say discrete and unordered, I usually mean nominal. And SPSS also says nominal. And that icon is 3 circles. So when I say that, I mean there's a nominal variable right there. It's got 3 circles. It means that each observation belongs to a group, and the thing that's recorded is what group it belongs to. The discrete variables that are ordered, I usually call ordered. SPS calls them ordinal. And if we were and they have this little, it's not showing up too well, so that's okay. Calls it ordinal and has a 3-bar icon. And continuous variables, which are not discrete but smooth, I call continuous. SPSS calls them scale, and its icon is a ruler. So this is what that looks like. So numeric value variables can be scale or ordinal or nominal, like a zip code or a rank or a measurement. String variables can't be scale. They have a little text next to the bars or the circles if they are discrete. And likewise, date can be any of the 3, and so can time. So these are sort of what the icons look like. Now, one thing that we might want to do when we're dealing with our data in SPSS is change a nominal variable from text to a coded number. So, for example, in the movie information, I have kids comedy written out here, or a sci-fi comedy, and this is a lot of characters, right? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters, spaces, and punctuation to keep track of this. But if we just use the numeric code like 1, that would just be a single digit. So it would be a much more compact way to store the data. And SPSS is designed to deal with like millions of lines of data, and that makes a real big difference there. So what you get, you can do automatic recode from the transform menu, and it will look at those variables and turn them into labeled codes. So when you push automatic recode, you get something that looks like this. Here's a list of different possible variables you could change. So I took genre, which was over here, and I pushed the arrow button and brought it over here, and then it said, where's the new name? So I typed new name category, and then see how OK isn't clicked yet. But when you push add new name, then this question mark area gets turned into category, and then you can hit OK. So don't forget to do that. And then the new variable is numeric, but still nominal. So here's genre, and there's category. It looks like it's the same, but what's going on here is that it's showing the value labels. And if I turn off value labels, I can see the code values, so 1 and 2. So this is more a compact way of storing the data. So SPSS stores a key that relates the labels to the codes internally and uses that to keep track of things, so you don't have to remember them. Another thing that we do sometimes when we're altering our data is we bin. We break continuous variables into discrete levels. There's a couple different ways to do this. There's visual binning, optional binning, there's recode into different variables. There's a couple different ways that you can do this in SPSS. I'm going to show you visual binning because it's the most intuitive. So if you pick visual binning, you get something like this. So I could pick a date that was scale, and it would show me a histogram of when all the dates were. And then what I can do, and it starts with high and unblank. And so anything up to but not including high is in the 20s. And then I created this cut point here, which is January 1st, 2020. And anything up to but not including that is in the teens. And I did that with 2010, so the aughts, and 2000, 90s, and then the last one is 90. So that when I finish entering this in, there'll be another red line, a red line here. This one will turn blue, and then I would label this 80s. So we have 80s, 90s, aughts, teens, 2000s. And then we could give it a new label and stuff like that. So that's how we cut data into bins. This is called a cut point, or we usually call it a cut point. Another thing we can do in SPSS when wrangling data is we can compute a new variable. So again, that's in transform, and this is the most general way of doing it because you can actually type in expressions like you would in an Excel cell. But instead of pasting to a bunch of cells, it just automatically applies to the whole column. So one common thing that we need to do is rescale a continuous variable from something like income, which has lots of really high values, but very, very high values, but mostly really small values. We might want to stretch out the differences between small things and squeeze together the differences between large things. So we might do a log transformation. So when you do a compute variable, you get this dialog that comes up, which is pretty complicated. It has a box here where you can type in your new variable name. You can't have spaces in it. If you want spaces, you can use this button to call up a label dialog and create a human readable name. This is the variables that can be used for computation. This is where the actual expression goes. This is for typing numbers and symbols. This are shortcuts for groups of functions. You can do all and see every possible function. And this is a list of all the functions that fall into the group you've selected here. And then if you select a function here, this panel gives you some information about what that function does. So we picked log 10, LG10, which is the log to the base 10, which that says. And there's a question mark here. And so if I drag domestic over here into where that the question mark is, if I selected that question mark and double click domestic, then it would go over there, and I can hit OK once there was at least one input variable in there. And then we could have this new thing where small values of income, this is the power of 10 here, so this is anything in the thousands, or hundreds of thousands, millions, tens of millions, hundreds of millions. So things get spread out. You can see that there as well. We'll talk more about logarithms later. Another thing you can do is you can take an existing complicated value like a date, and you can extract parts of it. So there's this date extraction function group here with all these different date extraction functions. So you could drag one of those up here, for example, X date year, and pull release date in there, and this would be release year. So that would turn just the year and then drop the month and date of each different value. So that can be really handy too. So that might have been an easier way to create our decade variable, for example, if we just extracted the year and divided by 10. So another way that we can select parts of a data. So that's transforming. The last thing I want to talk about for data wrangling SPSS is selecting the parts of a data set. So in Sheets and Excel, we filtered our data and that hid rows. In SPSS, we use this select cases command in the data menu, and that brings up this box. So there's the variables that we can work with, and then the different ways we could select. One way is we could select based on a time or case range. So I don't think this is actually correct, but it might have worked. I think this is if we had 2,000 cases, this would pick basically the last 10. So I don't think we would want to do this. What we want to do instead is this: select cases if condition is satisfied. Push this if button, and that pulls up this dialog, which is very similar to the compute variable dialog. The only difference is we don't name a new variable up here, right? So here's the input variables we could use. Here's the functions and special variables. And what goes on here is this is going to get evaluated for each line in the data set. And for each line, if this evaluates to 0 or false, false, then it will be excluded. And if it's anything other than 0, it will be included. So this part here, year greater or equal to 1990, that will be 1 if the year is greater than 1990 and 0 otherwise. Correspondingly, this will be the year less than 2000 will be 1 if the year is less than 2000 and 0 otherwise. And then this and joins those two together. So if this is a 0, then it doesn't matter what this is. It will be 0. So basically, if the result will be 1 only if both of these are true. So that gives films in the 90s. You can also put extraction things in here. So for example, if we take the title and we convert to lowercase with this lower function, and then we look for the word the, all lowercase, this will produce a 0 if it can't find the, otherwise it will produce the number where the index occurred, and that will be included. And so that will be a way to find any films that have the word the. So you can get pretty complicated with selecting cases. Then you hit continue, and you hit OK, and you're all good. So I hope that made sense. This was a little bit long and a little bit rushed.